Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled RNN-based Face Mask Detection Approach. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present one of the research area that we are working on in order to handle the health and the safety issues by detecting the face mask. So here the deep learning artificial intelligence models have been designed where it is presenting its better accuracy in predicting the face mask in comparison to the existing models. So before moving to the video, let's talk about what we will cover into this video. In this video, we will cover detecting face mask is helpful in which application area, where the real uses of these applications can be done. Then whatever the code we have designed, how to execute it, which file is to be executed, what dataset we have used, along with the software requirements will be discussed. Next to that, what are the current systems and what are the issues identified in them, along with what we have implemented and how we have implemented and which technique is considered will be discussed. Finally, the experimental outcomes and the findings will be explained in brief. So let's move to the application areas. While exploring the areas for the industrial human safety, where in the different industries, hazardous gases or the leakages, to avoid that for the human safety, the masks are recommended. So such system can be designed where automatically the persons are allowed with the mask only can be automatically detected. For the medical precautions, like any uh, virus was there as coronavirus was there, then in order to avoid the spreading of the virus from one person to another, the infection prevention, the masks are mandatory. So there these models can be implemented at the different public areas or the businesses or the industries. For the medical labs, the COVID-19 issue is the recent one, but from so many years, whenever working in the medical labs, doing the experiment with the different chemicals and gases, the face masks are recommended. So there the system can be implemented if it is detecting correctly. So number of issues can be avoided. For the mining, the miners, those are going underground to mine the coal or some other resources. In order to save them from the gases and the health issues, the masks are recommended. So all these areas are there where the mask detection is mandatory, not restricted to only COVID based mask detection. So inspired from this, we have implemented the model. So let's see how the code is to be executed. We will give you this folder. In this folder, you need to go to the code. All the data set and the files has been placed here. Along with that, these are the MATLAB files. So you must have the MATLAB software installed in your system. The recommended MATLAB software will be MATLAB 2018 or 19. You can use the higher version also, but make sure 18 and 19 are recommended, and it should be a full version, not the trial one. So to run this code, you just need to go to the folder. You just need to copy this path and go to the MATLAB and then paste the path here and press enter. When you press enter, you can see all the files those were there in the folder can be seen here. This is the main code file. So you just need to double click. It will open in the editor window. You can see it just opened in the new window editor where run command is there. You can just click on the run command and can get the simulation of the result. So I'm just running this code in the backend. Before that, let's have a look to the base paper that we are following. Here, this is the base paper that we are following, in which the facial mask detection in the smart cities has been done specifically for the COVID-19. The data set is considered from it, which they have captured from the CCTVs and all. Even some data is collected from the different resources in order to extend the data. So what they have done, they have implemented the model where they are detecting the face mask using the deep learning models. So the model that they are using is the CNN1, but we are recommending the proposed model in which we have done the modification in the two phases. One of the modification that we have made is like the images that we are capturing. These images are clear. Let's see an example of this one. This is the image where there is more blackish part, so it is hard to identify the area where the mask is. So we have applied the image enhancement technique for which adaptive histogram equalization method is implemented. Along with that, we have replaced the conventional CNN model, which is recommended by many of the person for the initial stage of the deep learning. We are using the residual graph model, a deep learning advanced model which to train the network, and then we are identifying the test data to check that whether our proposed method is performing well or not. So these are the modifications that we have made. So you can see how our proposed model is working. This is the processing of the data set. So what exactly it is? So I'm just raising it. This is the original images with the mask. This is the cropped image, that is the region of interest area. This is the lab color space we are converting the images, and then we are applying the adaptive histogram equalization and getting the histogram image. So you can see this graph is basically the actual histogram, and this is the enhanced histogram of the refined images of the cropped and main area. So it will take some time to process the whole data because the data set is so big. And finally, on that behalf, we are evaluating the system. So you can see it is processing. The data set is having the images like this. You can see this is the data set in which around 5,000 images are there. Even in the second data set, we have masked and non-masked images. Here you can see this is the data with mask. So this is a different data set we have used because the data set that was the previous one, that is not having the images without mask. So in order to train the network effectively so that they can differentiate between the masked and non-masked data, we have implemented it. So it will take so much time. So it will take around all the images to process. So I'm directly moving to the results section. So I'm just closing the simulation here. So control C, CLC. So let's see the code. Initially we are processing the image, cropping the image, then converting to the lab color space. Adaptive equalization, histogram equalization method has been implemented and dataset has been created. This is done for the dataset 1. Then in the dataset 2, masked and non-masked images are also processed in the same scenario. Final dataset is there. Then a residual method model has been implemented where the residual model is done in this particular code. So the data, whole data and the network information is given to this graph model, and the graph has been implemented. This graph is further given with the information that how many iteration, what is the batch size for training the data. Further, you can train that network by using this command, but we have already trained the system, so save the best result in the trained net system and then classified the output. The classified outputs are then the predicted outcomes has been shown in sent to the confusion stat calculation function where accuracy, f-score, precision, recall, sensitivity and specificity has been calculated. Then it is compared with the existing method. Those values are taken from the base paper directly. You can see the results has been given in the end of the uh, paper, so you can get the information from it. So this is the ROC curve they have used. The limitations are also given, and the results are also mentioned into it. So we have taken these results from the paper and then showed the result. So finally, the comparison for line graph, FSNet, EPNB, RGB, HGL, and Manifold is used. So these are the results that we have achieved from the proposed model. So this is the ROC curve that we have achieved, and these are the outcomes in terms of the accuracy. As you can see, the proposed accuracy term for all these scenarios has been with individual network is more. So we have also shown the results that we have achieved from the proposed one in the terms of the accuracy. So further modifications are still possible into it. So for any of the information related to that, you can contact us directly and can get the information. Thank you for watching the video. Stay tuned to our channel for more such uh, modifications and the real-time application developed by using the artificial intelligence in different areas. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.